we should leave on an excursion to acquire a more profound comprehension of our closest divine neighbor. To achieve this, we go to ALO-2, the swiftest man-made shuttle intended for noticing the sun. Its surprising rate of 157,000 meters per second, roughly 23% of the speed of light, permits us extraordinary bits of knowledge into our planetary group's focal star. However, as we think about the assets required for the colonization of far-off universes like the Alpha framework, the size of the errand becomes evident. Sending off a campaign to this adjoining star framework, even with our cutting-edge innovation, remains a far-off dream. The huge spread of room and the monstrous distances included highlight the need for exhaustive readiness and understanding. Alpha Place, one of the first star frameworks concentrated intently, holds an extraordinary spot in our grandiose investigation. It includes a couple of sun-like yellow small stars, Alpha Tauria and Alpha Centauri, which appear as a single star to the unaided eye. This paired framework, the third most brilliant star in the night sky, has caught the creative mind of researchers and narrators the same for hundreds of years. The charm of Alpha Centauri has been amplified by the investigation of exoplanets, planets circling stars past our nearby planet group. In spite of beginning expectations, two planets in the tenable zone of the Alpha Centauri framework, Focus N and Focus B, were viewed as unfriendly upon closer assessment. However, an advancement came in 2016 with the disclosure of Proxima and Conservative B, an exoplanet around 42 light-years away. Proxima and Peak B, with a mass like Earth's, ignited new expectation for the chance of tenable universes past our nearby planet group. Yet as researchers dive further into its attributes, new secrets arose, exceptional radio transmissions distinguished in 21 also, 19 inquiries concerning the planet's climate. While its short orbital cycle presented difficulties for maintaining life as far as we might be concerned, the disclosure of Proxima and Torb's puzzling neighbor, Proxima Peak D, further grows the opportunities for investigation and study. While its tenability remaining parts unsure, it offers enticing possibilities for future examination and highlights the tremendous exhibit of unseen universes holding up to be investigated. To uncover these far-off domains, space experts depend on refined observational strategies. The travel technique, noticing stars for changes in splendor as planets pass before them, and Doppler spectroscopy, recognizing changes in starlight brought about by gravitational association with circling planets, are among the essential techniques utilized. These techniques have prompted the disclosure of thousands of exoplanets, each offering an extraordinary look into the variety of planetary frameworks. Yet, as our observational capacities advance, so too does how we might interpret the universe. The revelation of Proxima and Torb and its adjoining world is a demonstration of the force of human interest and the persevering through journey for information in the tremendous scope of room. Each disclosure opens new roads for investigation and ignites new inquiries about the idea of our universe. As we keep on pushing the limits of our understanding, the quest for exoplanets will stay at the front of logical request, driving us ever closer to opening the secrets of the universe. Contemplating exoplanets uncovers significant possibilities past the simple journey for recognizing life somewhere else. It's tied in with widening our skylines, propelling humanity's reach across the immense universe. While pondering the possible livability of far-off universes like Proxima and Torb, we are provoked to consider the complexities of life past Earth's limits. The James Webb Space Telescope, JWST, remains as an encouraging sign and progress in humanity's mission to disentangle the secrets of the universe. Booked to leave on its main goal in the late spring of 2022, the JWST addresses a quantum jump forward in how we might interpret cosmology and the universe's magnificence. With its trend-setting innovation and remarkable abilities, the telescope vows to reform our understanding of the universe in manners already incredible. At the core of the JWST mission lies its essential objective: to notice far-off GXYZs and open the privileged insights of the universe's earliest stories by looking profound into reality. The telescope will catch light from the main cosmic systems that framed billions of years prior, giving significant experiences into the inestimable cycles that molded our universe. As well as contemplating far-off universes, the JWST is ready to play a vital job in the quest for life past our planetary group. Outfitted with cutting-edge instruments including spectrographs and imaging cameras, the telescope will examine exoplanets circling far-off stars for indications of livability. One of the critical elements of the JWST is its capacity to examine the environments of exoplanets with exceptional accuracy. By considering the peace and construction of exoplanet environments, researchers will actually want to identify key particles that could demonstrate the presence of life, like oxygen, methane, and water vapor. In addition, the JWST's progressed imaging abilities will permit space experts to notice straightforwardly exoplanets circling close by stars, giving itemized pictures of their surfaces and elements. This will empower researchers to concentrate on the environment, geography, and expected tenability of these far-off universes more meticulously than ever before. One of the most dissecting focuses for the JWST is approximately Center B, an Earth-sized exoplanet situated in the tenable zone of Proxima Center, the nearest star to our sunlight-based framework. Notwithstanding the difficulties presented by Proxima Center's continuous flares and extreme radiation, researchers accept that Proxima Community B might actually harbor fluid water and likewise life. Utilizing its high-level instruments, the JWST will concentrate on Proxima Place B's climate for indications of livability, including the presence of water vapor, carbon dioxide, and other key atoms. By examining the light that passes through the planet's environment, researchers will actually want to reason its organization and construction, giving significant experiences into its capability to support life. The JWST's perceptions of Proximus and Peak B could yield notable revelations that reshape how we might interpret exoplanets and the probability of life past Earth. Whether Proxima and B ends up being tenable or not, the information gathered by the JWST will give significant data about the variety of planetary frameworks in the universe and the circumstances essential for life to emerge. Past its logical goal, the JWST addresses a demonstration of human resourcefulness, cooperation, and constancy. The telescope's advancement included commitments from researchers, engineers, and experts from around the world cooperating to defeat specialized difficulties and push the limits of space investigation. The JWST's excursion to its last objective, AL2 Lagrange Point, a stable circle found around 1.5 million kilometers from Earth, is a demonstration of the striking accomplishments of human spaceflight. Once functional, the telescope will leave on a mission of revelation, looking profound into the universe and uncovering the secrets of the universe. As we anticipate the JWST's first light, expectation works for the abundance of bits of knowledge it will uncover about our universe, from the earliest minutes of vast history to the quest for life past Earth. The telescope holds the commitment of changing our comprehension of the universe and our place inside it. In the fabulous plan of grandiose investigation, the JWST addresses an encouraging sign and motivation for people in the future. Its heritage will persevere long into the future, forming our comprehension of the universe and moving new ages of researchers, architects, and pilgrims to push the limits of human information. All in all, the James Webb Space Telescope remains as a demonstration of human interest, creativity, and desire. With its progressive capacities and exceptional accuracy, the telescope vows to alter how we might interpret the universe and open the mysteries of infinite development. As we leave on this excursion of disclosure, we are helped to remember the unfathomable capability of human investigation and the persevering through journey to unwind the secrets of the universe. One of the telescope's critical targets is to recognize the presence or non-attendance of an error on Proximus and Peak B. An environment B distinguished could imply conditions helpful for life. Also, the telescope's high-level capacities extend to measuring a planet's infrared radiation, determining its pivotal slant, and measuring its size comparative with its star vital boundaries for evaluating livability. Looking farther ahead, forward leaps in space travel fuel our minds. The Advancement Starshot project, but in its theoretical stages, imagines sending light sail-prepared space apparatus to the Alpha Center framework powered by lasers. These rockets could accomplish speeds approaching that of light, possibly arriving at the framework in 20 to 30 years. This aggressive undertaking could lay the preparation for humankind's possible colonization of universes. Space exploration, with its fabulous yearnings and visionary projects, frequently captures the imagination with its commitment of new discoveries and potential for interstellar travel. However, amid these grand objectives, It's essential to face the unforgiving realities that accompany exploring the universe. One such reality is the difficult conditions presented by stars like Proxima Centauri, which cast doubts on the tenability of planets in their area. Proxima Centauri, a red small star situated in the Alpha Place framework, is known for its frequent flares and serious radiation. These heavenly peculiarities establish a climate that is adverse to life as far as we might be concerned on the planet. The extraordinary radiation and unusual flares could strip away any potential air and make the outer layer of close by planets aloof to life forms that depend on ordinary conditions. Regardless of these overwhelming challenges, the hypothetical chance of life on planets circling Proxima Centauri perseveres, fueling the imagination of researchers and sci-fi aficionados the same. One situation that is frequently considered is the presence of underground or seagoing organic entities that could flourish in conditions safeguarded from the destructive impacts of heavenly radiation. Underground life structures, for example, could exist underneath the surface of a planet like Proxima Centauri B, where they would be safeguarded from the harming impacts of solar flares and radiation. These organic entities could possibly harness geothermal energy or other alternative sources to support themselves without any sunlight. Comparable amphibian life forms could flourish in profound seas or underground repositories, where water goes about as a safeguard against unsafe radiation from the star. These conditions, albeit testing, offer the chance of supporting living things adapted to outrageous circumstances similar to those seen as in Earth's generally unfriendly living spaces. The possibility of life existing in such outrageous conditions isn't without point of reference on Earth. Researchers have discovered living things flourishing in some of the most unfriendly conditions possible, from profound aqueous vents to acidic underground aquifers and frozen Antarctic lakes. These extremophiles, as they are called, exhibit the strength of life and the flexibility of organic entities to an extensive variety of conditions. Hypothetical models and recreations offer further help for the chance of life on planets circling stars like Proxima Centauri. These models consider factors, for example, the planet's separation from the star, its air structure, and the presence of defensive elements like attractive fields or thick environments. While the presence of life on planets like Proxima Centauri B remains speculative, the quest for information drives researchers to investigate these far-off universes, looking for replies. High-level telescopes and space tests outfitted with cutting-edge instruments empower cosmologists to study exoplanets in extraordinary detail, giving significant experiences into their creation environment and potential for livability. One such instrument is the James Webb Space Telescope, JWST, booked to send off in the close future. The JWST's advanced abilities will permit researchers to study exoplanets with extraordinary accuracy, offering new open doors to distinguish indications of something going on under the surface. Beyond our solar system, the telescope's capacity to break down the air arrangement of exoplanets could give vital insights about their livability. For instance, the presence of specific gases like oxygen, methane, or water vapor could demonstrate the presence of life processes on the planet's surface. As well as examining exoplanets, the JWST will likewise shed light on the arrangement and advancement of worlds, stars, and planetary frameworks, giving important bits of knowledge into the beginnings of life in the universe. By looking profound into reality, the telescope will assist researchers with unwinding probably the most significant secrets of the universe. Beyond the logical mission for information, the quest for life past Earth has significant ramifications for humankind's position in the universe. The disclosure of extraterrestrial life, even in its simplest structures, would alter how we might interpret science, development, and the potential for life to exist elsewhere in the universe. Also, the investigation of far-off universes offers new open doors for human extension and colonization beyond Earth. While the difficulties of interstellar travel are considerable, visionary activities like the Forward Leap Starshot drive envision, sending shuttles outfitted with light sails to nearby star frameworks, possibly clearing the way for future human missions to different planets. In the end, the journey to overcome space is a demonstration of the human soul of investigation and disclosure, joining individuals from varying backgrounds in a common try to open the mysteries of the universe. From old developments looking at the stars in amazement to present-day cosmologists looking profound into the universe with cutting-edge telescopes, the mission to comprehend our spot in the universe has been a consistent all through mankind's set of experiences. As we stand on the verge of another time of room investigation filled by headways in innovation and logical comprehension, the opportunities for disclosure are unending. The James Webb Space Telescope, with its unmatched capabilities and progressive instruments, holds the commitment of uncovering new bits of knowledge into the idea of the universe and the potential for life past Earth. Its perceptions of far-off universes, exoplanets, and vast phenomena will shed light on the key secrets of presence and guide humankind on its excursion to the stars. Yet, for all our mechanical ability and logical resourcefulness, the investigation of room stays an overwhelming undertaking loaded with difficulties and vulnerabilities. The brutal states of room, the tremendous distances between divine bodies, and the cutoff points of our ongoing comprehension of material science present considerable impediments to survival. However, it is unequivocally even with these challenges that the human soul sparkles most brilliantly, driving us to push the limits of what is conceivable and reach for the stars. In the excellent woven artwork of vast investigation, each new revelation fills in as a string woven into the texture of human information and understanding. As we adventure further into the profundities of space, recalling that is fundamental, the excursion itself is just about as significant as the objective. It is an excursion fueled by a hunger for information as well as likewise by a firmly established feeling of marvel at the boundlessness and magnificence of the universe. In the end, the journey to overcome space is a demonstration of the unlimited potential of the human soul. It is an excursion that provokes us to reach past our cutoff points and seek to significance. And it is an excursion that eventually helps us to remember our place in the universe, not as aloof spectators but rather as dynamic members in the ongoing story of creation and disclosure.